8.1 Model Inverse and Joint Variation. So we're going to start with these tables. Start by calculating x times y. So 20 times 10, we get 200. 22 times 11, we get 242. Go ahead and fill out the rest on your own. And then we're going to calculate y over x. So take these two and divide them. Y divided by x. So 10 divided by 20 gives us 0.5. 11 divided by 22 gives us 0.5. All of these give us a constant of 0.5. And since y over x is a constant, this is going to be what's called direct variation, and it matches with this equation. So basically you can always multiply x by 0.5 and you'll get y. That's direct variation. Next, we'll look at one that varies inversely. So, start by doing x times y. 1 times 20 gives us 20. 2 times 10 gives us 20, and so on. We get 20 for all of them. So that means that xy is constant, which means that this is inverse variation. So in this case, we can always take our constant, divide it by x, and get y. So go ahead and label those inverse variation, direct variation. And then we also have joint variation, which just means that there's two variables. Looks a lot like direct variation, but there's two variables, so we have the x and z. A is what we call the constant of variation. Next, we're going to classify each type of variation, direct or inverse. So you're going to start by making them look like the equations we have above. So I'm going to start by adding 3x to both sides, and we get y equals 3x. That means that this looks like y equals a times x, so that is direct variation. We're also going to identify the constant. Of variation. So in this case, a equals 3. Okay, B. X equals 7 over y. Well, we want it to look like one of these, so we're going to rearrange it for y. So multiply by y on both sides. Y's cancel on the right. We get xy equals 7, and that looks just like inverse variation, where we have xy equal to a constant. So what we can do now is rearrange it for y. So divide by x on both sides. We get y equals 7 over x. Our constant of variation is 7, and this is inverse variation. Okay, and C, let's rearrange for y. Subtract 5x from both sides. We get 9y equals negative 5x plus 4. Divide by 9. We get y equals negative 5/9 x plus 4/9. Now, this doesn't look like either equation. It almost looks like direct, but we have this plus 4/9, which makes it not direct. This makes it not direct, but linear. So this is neither. Then we have xy equals 8. Try this one on your own. Pause the video. Get y by itself. We divide by x. This looks like inverse variation. A equals 8. Okay, next we're going to be writing some inverse and direct variation equations. So if x and y vary inversely and y is 15 when x is 1/3, write an equation that relates x to y. So we're going to start off with our inverse variation equation, y equals a over x. And then we're going to plug in the numbers they give us. So y is 15, a we don't know, and x is 1/3. And then we're going to solve for a. So let's multiply by 1/3 on both sides, get rid of that 1/3. 1/3 of 15 gives us 5. So our constant of variation is 5. Let's put it back into the equation. Y equals 5 over x. There's our inverse variation equation. Then find y when x is -10. So now we're going to take this, plug in -10, and we find that y equals -1/2 when x equals -10. Try the next one on your own. This one is direct variation, so we're going to use the equation y equals a times x. We're going to plug in -12 for y, x is 15, and then we're going to solve for a by dividing by 15 on both sides. Now, -12 over 15, I could simplify that. They're both divisible by 3, so we're going to divide the top and bottom by 3, and we'll get -4/5 equals a, so our equation is -4/5 x. And then use it to find y when x is -5. Y equals -4/5 times -5. This is like -5 over 1, so I can just multiply the fractions. 5 over 5 cancels, makes 1. Negatives, 2 negatives make a positive, and we get +4. On to the back. Okay, so we have this situation. The driving time between two specific locations varies inversely with the average driving speed. The driving distance between Chicago and Minneapolis is about 400 miles. So let's go ahead and write the equation that they give us. So as they said, the driving time between two specific locations varies inversely. That means that I could set time equal to some constant divided by average driving speed. So this constant is actually going to be the distance, because the distance is not changing. And that time is equal to 400 over the rate or the speed. Okay, so we've got our equation. We know that this is inverse variation, which means that as the speed goes up, the driving time goes down. And then let's fill out this table. So we're going to take 400, divide it by 32 to get the driving time, 12.5. If we go 40 miles per hour, 400 divided by 40 gives us 10 hours. If we go 50 miles per hour, it's going to be even shorter. We're going to get 8 hours, and so on. Okay, next we have moving cartons. These are manufactured in a variety of sizes and shapes to accommodate the variety of objects that need to be packed. The table compares the area, A, of the bottom of a rectangular carton in square inches with the height h for 4 available cartons that have the same volume. Let's underline that, the same volume. So there's a constant here. Let's figure out what it is. So write a model that gives h as a function of a. Now, if we think about area and height and how they're related to volume, we know it's v equals area times height. And since we know this is constant, well, that looks just like inverse variation, where a is equal to xy. So we can even test it out. 50 times 24 equals 1200. 100 times 12 equals 1200. 120 times 10 is 1200. So our equation would be h equals, h as a function of a would be v over a, and since volume is 1200, it's 1200 divided by the area. Okay, so let's write another sentence here. As area goes up, height goes down to keep the volume constant. Use the model to predict the height of a carton with the same volume as those in the table that has a base area of square inches. So h equals 1200 divided by 75. That gives us 16 inches. Next, we're going to practice writing some equations just based on the wording. So again, inversely is going to be the one where we have division, y equals a over x. In this case, it's r varies inversely with s, so it's r equals a over s. This next one is jointly, the one we haven't seen yet, but it's just like direct. Y equals axz, but it has two variables. So in this case, we're doing z varies jointly with x and the square root of z. So you put the constant out front, a, and then x, and the square root of y. Next, p varies inversely with the cube of q. Try this one on your own. Should have gotten p equals a over q to the third. So inversely, that's where the division comes in. Constant always goes on top, and then cube of q goes on the bottom. D, m varies directly with the square of n and inversely with p. Try it on your own again. So this one's a little funky because they said directly with the square of n, so that one has to go on top. And then inversely with p, that means that one's going to be divided. That'll go on the bottom. Next, z varies jointly with u, so a times u, and v times v, and inversely with the square of w, so on the bottom, w squared. And last one is a check your understanding. Truly, make sure you try this one on your own to see if you understood what we did today. But this says the variable z varies jointly with x and y. Z has a value of 60 when x is -4 and y is 5. Find z when x is 7 and y is 2. Start by writing my basic skeleton of my equation, and then I'll plug in 60 for z, x -4, y is 5, and then solve. Get 60 equals -20a, divide by -20, and I get -3 for a. So if I write my equation, I get z equals -3xy. Then find z when x is 7 and y is 2. So z equals negative 42. Don't forget to like and subscribe.